Hi everyone, we're going to use the principle of mathematical induction to show that the given statement is true for all natural numbers n. This is our sequence here, along with the sum. The nth term is here, and this is the sum. So we have to show that condition 1 and condition 2 hold. Hopefully you watched the easier problems, 1 through 7, because I tend to go faster and faster. So anyway, we're going to check for n equals 1. I'm going to plug in 1 into the sum here, and it should equal my first term. So this is going to be 1/2 times 1 times 3 times 1 minus 1. A lot of parentheses. So anyway, that we don't even need that. So we get 1/2 times 3 minus 1 is 2. 1/2 of 2 equals 1. So it checks. Now, if this works for some natural number k, so I'm going to write 1 plus 4 plus 7 plus dot 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 plus 3k minus 2. And everywhere there's a n, I'm going to put k. So condition 2 is if it works for some k, then it should we're going to prove that it works for the next term, k plus 1. Okay, so I'm going to copy this guy down here, this sequence. It's just arithmetic, by the way, and the common difference is 3. And there's your 3 right there. You can see it. There's another one there. So I'm going to show you a better way of writing the next term. So I wrote him down, and the next term is just going to be, we're going to take, this is linear. Remember, arithmetic sequences are linear. So this is like the slope. This is like the y-intercept. So we're going to add the 3 to the y-intercept, the slope. We're going to copy him down. So this will be 3k. Negative 2 plus 3 is 1. And that's how I get the next term. Then we're going to write this, 1/2. And we know the next term from k is k plus 1. And I'm going to do the same thing with this portion. My slope is 3, so the common difference is 3. We're going to add 3. So I copy 3k, and negative 1 plus 3 is 2. And that gives you your next term. Now, I'm going to write him down. So again, 1 plus 4 plus 7 plus dot dot dot. 3k minus 2. Actually, I'm not going to write him down. Sorry. What I'm going to do is I notice that this equals this right here. So I'm going to, the summation, so I'm going to erase this. It's kind of confusing. So I'm going to write down the sum of this, which is 1/2 of k times 3k minus 1. Then I'm going to add my new term, my next term, and this should equal this over here. And again, this is one of those things where we have this 1/2 outside. This 1/2 on this left side only goes with this portion, and I want it to also go with this this straggling guy over here. So in order for him to kind of join in, you can do the common denominator thing. But all I'm going to do is, since my it's 1/2, I'm going to multiply this portion by 2 and let him join the group here. So I have 1/2. I'm just going to copy k times 3k minus 1. And then I'm just going to multiply this guy by 2. Alright? So now he's in the group with this group with the 1/2 on the outside. That's what we want here on the right side. Now let's go ahead and clean up this quantity in the middle. And we get 3k squared minus k plus 6k plus 2. And further simplifying, we get 3k squared plus 5k plus 2. And when you factor that, you're going to get k plus 1 times 3k plus 2. It should equal this side. If you don't agree, you can FOIL this out and make sure it matches right there. Okay, so we have proven that which was to be proven by showing that conditions 1 and conditions 2 hold. Thank you and have a nice day. Bye-bye.